Once you go into it, you will see the name Excel. Yeah. Okay, you might not be able to see it, but just search for it under store. Just search for it and then click on add after you have done that. So in case you have any question, just drop it on the chat section. I shall be able to see it and then I shall respond to it. Okay, so let's get into it. So as promised, we are going to look into probability, a lot of probability functions, and then the last session, which shall be next week, shall be looking at financial operations. So I'm going to start with descriptive analysis. I'm going to start with descriptive analysis. So we are just going to be able to get a brief description of what or how our data set is looking like or what it has. So I hope. So with that being said, the first data set we have is the female and male. Don't type all that you can see, everything else, just type female and male. Just this, I think there's six data for the female and 5 for the male. So what we are going to be doing is we are going to analyze the study time for male and for female students and 6 female students and 5 male students. So the first thing we're going to do is just analyze that data. So to do that, we shall just I can cancel this out for now. Yeah. Okay. So you are going to come in. Actually, I don't know why I have cancelled that. We're going to use that extract cloud. So okay. So while it's loading up, there are many operations that the extat, or of course even for those of us who have done mathematical courses, we know that there's probability 1, probability 2, probability 3, up to probability 4. So there are so many operations that can be performed. So I don't know why this is acting up. Okay, home. I don't know if it's my network. So I bet for those who it has opened up, it should give us a green interface. that you can be able to interact with. Are you using the online Excel or the on Office? Yes. Microsoft Office 365. That is what I'm using. So because I have a Linux system, so I just opted for that. I don't know if I click on any. Let's see. I should refresh this. Let me refresh this. Sorry for that. I hope I didn't cancel that. So let's see. I was opening the wrong one. Yeah. Okay. So I just had to refresh my browser. So I'm going to start with descriptive analysis. So we're just going to get an overall feel of how our data set is or how it is operating. So remember we are using the female and the male. So you can just type that out. So you will see a section, you can see the tool pack that this miner is able to give us, the Anova, which is like the full name is analysis of variances, two-factor with replication, two-factor without replication, and then we have the correlation, we have covariance, descriptive statistics, we have exponential smoothing, we have F-test, two samples of variances, we have Fourier analysis, we have the histogram, linear regression, logistic regression, moving average, random number generation, rank and percentile, sampling, t-test paired, two sample of means, t-test, two sample assuming equal variances, t-test, two samples assuming unequal variances, and z-test, two samples of means. So that's just what we are able to get, and I think that's because that's what is available for free. So I feel like if you upgrade and probably get the paid version, it it comes with more, or there are actually other tools or other add-ins which add more functionality depending on what you want. So I want us first to start with the descriptive. So for you to be able to get the descriptive, so I will just transfer this data set so that we can just see how it is operating. So I'll just add it to a new sheet. So now when you're coming and talking about the descriptive, so you'll click on the descriptive and then you'll see this drop down, and then now you'll give your input range. Where do you want this to range from? So our first value is at A2 and our last value is at B6. So that's where we want it to range, but you're going to still specify for each column that it's not just from A2 up to B6, it's from A2 up to A7 over here, from A2 up to A7, then from B2 up to B6. I'm sorry, my mind is hanging. Yes, so that's what you're going to do. So I'm just going to come ahead and say, first you start with a dollar sign. Note I am on this end now. Start with a dollar sign. So it's going to be from A2. So put your A, then put another dollar sign, and then 2, and then now your range from A2 for that specific column up to another dollar sign, A, $7, and then wait, let me try something. I think this one I can just put it as is because I don't have two intervals from B2 from up to B6. Let's see if it will work. And then our output is where you want your output to be displayed. So we can say at D1. So same thing, D1. Okay. So you can see it has the confidence interval if you want to get it on a certain confidence interval. So I'm just going to leave that for now as is. That the default is 95. So if I just click OK, you can see what it goes ahead and gives us. I don't know why it does. Oh yeah. Oh, I know what has happened. So what has happened is it has first done for column A separately and then for column B separately, but that's not what we wanted. So let me just try something. Up to A, sorry, A, A7, and then comma from a dollar sign from B $ to B $2 up to $B $ again B6. Did I put okay? Yeah. Okay, let this be from J $1. You know, I have an issue with that, so the input range is invalid. So okay, so it has just done the same thing. So I guess it is what it is. So we don't need this, it's still the same thing. So yeah, let us come to our input and see what it has given us. So for column A, I'm just expanding. So for column A, which has given us the first value is 26, it shows us that the mean is 30, the standard error is 5.43, and etc. And then the median is 29.5, and then the mode is 43, standard deviation. You can see all that: sample variance, kurtosis, skewness, range, minimum, maximum, sum, count, largest, smallest, confidence interval. And it does the same with the B for the males. So that is the descriptive analysis. So we are just able to get an analytical feel of how our data set looks like. Okay, so I want to move on. So another option that Excel just gives us without having to add the add-in is just on the top, on the home button, you will see the analyze data. So it just goes ahead and analyzes the data for us and gives us charts to show us. Probably you don't need all these. You don't need the mathematical operations. So it goes ahead and just explains us. We see we have like a scatter plot for male and female. We have a bar chart. We have a pie chart. We have a line graph, and it goes on. So you have the option to choose. You have an inverted. So yeah, so you can be able to click on insert chart and it will be displayed on your worksheet. Okay, so that was the first one. So let me just remove the analyze data. So I can see, okay. Oh yeah, that's for different one. I'm sorry. Okay, so we have that. So I want us to move on to the F-test. The F-test. So the F-test is used to test the null hypothesis that the variances of two populations are equal. So the null hypothesis of the F-test is that it assumes that variances are equal. So the alternative hypothesis is the variances are not equal. So we shall be able to compare that and see if our data is, if we reject the hypothesis or we accept the hypothesis. So in the assumption that you have an idea of when I talk about null hypothesis and um, the alternative hypothesis. If you don't, um, it's just us having first like a basic and then proving that or having a default and then proving that default is not really the default or is not really the concluded. What do I mean? Like we can say like, oh, you have a null hypothesis that transport from Nairobi to Nakuru is 300 shillings. And then, or maybe the fuel consumption that you're going to use to drive from Nairobi to Nakuru is around 1,000 bob worth of fuel. And then somebody goes ahead and performs a research or takes in data, and then from that data they are able to test if that null hypothesis is true or false. So if they are able to find that, oh, it's actually not 1,000 like you had said, so we can reject that hypothesis. So that is just a basic description of what that is. So yeah, I don't know if my net has disconnected me. Okay. So yeah, so let us move on and look at F-test. So remember for F-test, we are comparing variances that and the null hypothesis now in this case is that the variances are equal. So we are going to still use the same data set for the male and the female students. So I'm just going to come ahead and okay. Yeah, we can still just use this interface. So I'm just going to, okay. First in your XLMiner, you're going to go to where we have F-test. And so we have the two sample of variances. So this one gives us, you're comparing two values that the variances are the same. So you can see it gives us variable range 1 and variable range 2. So we are going to pick the range of this first column. So our range, remember, I put it in dollar signs. So A up to from A2 to separate the nini, put the range or the next value, put a full colon and then dollar sign up to A. So this one you have to specify where the column is going to end. So from A2 up to A7, and then from B2 up to B6. So you can see it has an alpha. So the default one, according to the software, is 0.05. So sometimes you may be told, find the F-test or find the alternative hypothesis So, okay, for those who are in campus, you might know they don't really tell you that you're finding the F test. It's just by looking at how the question is, if you're comparing variances, I'm going to use the F table. So that's just, it's only that here you have the advantage of knowing what you have. So you're going to be told, find the alternative hypothesis, not for those who are in campus, for those who are doing mathematical courses. So find the alternative hypothesis, where the alpha is, or the confidence interval is 0.05 or zero point 0.5 or 0.1. So there's that, it changes. So for this case, we're just using 0.05. And then the output range is definitely where you want your data set to be displayed. So just be aware of that. So I'm just going to pick from, display this data from J1. So that one doesn't have a limit. You are the one who's going to just look at how your data looks like. So let us click OK on that. Yeah, so here's our data set. Just going to scroll, increase this so that you can be able to see everything. So that is what we have. So that is our F-test for 2 sample for variances. So it gives us, so 26 and 23 are just the first values in our columns, just to guide us on what is what. So the mean for the first one is 34.4, and then the other one is 25.25, and then the variance for the first column, or column A, is 185.3, and the other one is 27.5833. The observations are 5. 4 for the other one. Degrees of freedom, is normally, the formula is normally n minus 1. So 4, so they just take 5 minus 1, 4 minus 1, that's 4 and 3. And then we have F being 6.71 7825. So manually you get it by dividing 185.3 divided by 27.58, blah blah blah. And then the PF is that 0.0, so that can be read by the table, and then the critical tail is that. So with that being said, you have to just make sure that the variance of A is higher than the variance of B. So in our case, 183 is definitely greater than 27.583. And then we are now going to go ahead and compare the F, this F, with the F critical one tail. So when I compare that, I realize that F is less than F1, F critical one tail, meaning I accept the hypothesis. If it was the other way around, I would have rejected the hypothesis. So if it was F is greater than this, I would have rejected the hypothesis. So for me, something that really stood out, the formula test. Christopher, what do you mean by the formula test? I don't know. I'm not sure I get that part of the question. Okay, I just wanted to point out something, and probably if you're doing this on your research, you're going to tell us why this is different. So if I come here and I just highlight that part, probably, yeah. So if I come here to my AutoSum and I click on more functions, so if I click on statistical, so I don't know if it's because it's n minus 1, I don't know, but If you go to, but you're going to tell us now. This is like part of your homework. So, what am I looking for? Variance. Sorry, my mind is copy and sample. Okay, I think I'm going to pick that one. Variance as sample. So this is, I'm just finding there. Okay, no, I've input that in the wrong place. So the first value was 26. So I'll go to where I want my output to be seen, and that's where I'm going to click on. So if you just know the commands directly, you can just type it as equals and then type. So I wanted to show you guys something. Actually, when I used this, because also this has an F, it has an F test here. When I used this, actually, let me use the F test. Let us see how this will be different. So when I said A2 up to, I notice I'm not using dollar sign, up to A7, comma, B2 up to B6. If I click on that, what were it? That's 0.70755. So you can see it's different. The answer is a little bit different, though not that much, but it's a little bit different. You have 0.7577 and this one is 0.74. No, but there's something I spotted. Let me do the one for variance. You see what I mean? So this actually, I tried to think what might be the reason. And let me see. Or probably maybe I'll spot something I hadn't spotted when I was trying to do it. Up to A7. 160. Yes, you see this comes as 160, while for this it was 185.33. So that is something I realized, and I feel like for this it was also a little bit smaller. It wasn't 160, it was something else. It was something else. So if you figure it out, share with us why that is the reason. So yeah, it was something else. I don't know, it was 27. So you can just get it directly 160. Yeah, 7577. Okay. Let me do it. So it was, if the statistical variance. So I remember there's something like, there are two different ways of getting like the variance. There's the one for n-1 and the one just for n. So I don't know if that is what was happening in this case, but I wasn't able to figure it out. Yeah, so you can see this is 21.7, while for this it is 27.58. blah blah blah. So remember, the Fisher's is normally gotten by the division of 160 divided by that, you get 0.0. So for this one, even if yes, if you divide, you'll get you 6 point something. Is it 6? You just confirm if it is the second value or the first one, not to misguide. 27.5883. Yeah, it's the 6.71778. You can see. Well, for this, it was totally different. It's totally different, yet it's the same data set and everything. So that was a little bit tricky. Actually, for this, it was no. When you divide 160 by 21.7, you get. What is this? I think it's this 0 point. But when you divide this, you get 7.3. Even you can just do it here. You can say is equals to 160 divided by 21.7. You can see get 7.373. So you see, it was because when I used this, I rejected the hypothesis. But when I came in and used the XLMiner, I had to accept the hypothesis based on whatever values it was giving me. So if you figure out how that is happening, just share with us. But I feel like, I don't know but yeah, that is that. So principal Latin formula, as in you have stated that F is obtained this over that. So for example, if I have a sheet on PC, I would know does the placing of the cursor. No, it will. No, the problem is without the tool pack, I realized it's so hard for us to get things like this, the one till, the critical. With the tool pack, it's able to do that immediately. So I know probably if you are late or something, just go to your insert. You will find office add-ins. Click on it. Once you click on it, it will take you to a store. Look for XLMiner analysis toolpack. And then you shall be able to click on add, and then it shall be added to your Excel. So I hope that helps you out, Christopher. So yeah, other than that, we can move on. So that is our F-test. I hope we have all been able to understand. I know I have added more information with the differences, but you understood what we did. We compared the variances. That's what our F-test does. They are not the same. So we went ahead and found the F value, and then the analysis toolpack was just able to do everything for us, and we were able to find the critical and this. So once I compare this to this, if this was greater than this, I would have rejected the hypothesis, but for this case it is less, hence I had no option but to accept the hypothesis. So I'm going to move on to Anova. And like I mentioned, Anova just stands for analysis of variance. So a single factor or one way Anova is used to test the null hypothesis. That means that the means of several populations are equal. So now for analysis of variance or Anova is that we say that H naught, I don't know how I can be able to write it here, but H naught stands for the null hypothesis. So for this case, you're assuming that your mu is equal, mu1 is equals to mu2, which is equals to mu2, which is equals to mu3. And we are investigating the alternative hypothesis H1, where at least one of the means is different. So with ANOVA, the null hypothesis is that all the means are the same, and then the alternative hypothesis is that at least one of the means is different. So let's go ahead and do that. Let us go ahead and do that. So I hope, Christopher, you have been able to get that Office add-in. So first we shall yeah. Okay, so we are going to use Anova single factor. So our data set shall be this one: economics, medicine, and history. So what we are going to do is we are comparing the salaries of those who have a degree in economics, those who have one in medicine, and those who have one in history. So you can just go ahead and note that down. So so with that, click on Anova single factor. So I can easily just copy paste this data set to a clean sheet. To it to a clean sheet, which I'll just use this. There it is. So we are going to pick our input range. So for this, I can directly go in and put in my input range. So it is from O2, so O2 up to Q10. Oh no, remember you have to put a $sign to separate that. Full colon up to Q 10. So I feel like with the toolpack, it helps, especially those people who have not been able to really interact with this side of mathematics, the statistics side of mathematics. So it's just direct. It's able to do everything for you. Alpha it's just the confidence interval, so it can be different. And then the output range is where you want your data set to be, the output to be displayed. So I'm just going to display it at S1. So I'm just going to say that S1. Okay, and then let us click OK. So okay, I didn't need labels, but it's okay. Yeah, so this is our output. Let me just increase this bit first. Okay, so let me just move that there. So the first thing that it does, it shows us the groups. So groups are just it's economics, medicine, and history. It's only that it's giving us the first value of each column, just for us to know the distinction. Count is just the number of elements in each. I think it's Okay. Yes, yes, Christopher. I hope you have gotten the office adding. I don't know if that's a question to incorporate in maybe. So sum is just the sum, average is the average of each column, and then the variance of each column. And then now we go to our analysis of variance. I have the source of variation. So we have sum of squares, you have it there, and then you have the degrees of freedom, and then I think it means square, and then our f, our p value, and our f critical. So and then we have our total, and then our degrees of freedom total. So from what we can see is that the means are different, first of all. So with that, you can now go ahead and get and know if you're going to reject or accept. So for you to know, you're going to compare your f. If it is greater than the f critical, you're going to reject the null hypothesis, meaning that the means of the populations are not all equal. So, of course, directly you can be like, yeah, the means are not all equal, but you just have to proceed and get the F value and now conclude that you have rejected the null hypothesis. So, the thing is that with the ANOVA, we are not really able to know, okay, so which mean is not equal to which mean, so it's not equal to the rest. So to be able to get that, we now move on to what we call the t-test. We move on to what we call the t-test. So any questions so far, because I want to get on to the next one, that is the t-test. Or as you stated in the second row, as labeled by starting by, that's why the groups are the first row and counters off by one. Christopher, at this point, can you just unmute yourself and explain what you're texting? I don't think I'm understanding. Is it the same for the other ANOVA? The two-factor with replication and without replication? I don't think so. I don't think so. I don't think it can be the same. So the procedure, okay. The procedure, so here it is. You see, for this you have the input range and then the rows per sample. And then I think the only difference is the row per sample. And then for without input doesn't have the row per sample. So I think that's the only difference. But Excel just makes everything the same. So Christopher, so if the input is starting from one and not from two, what's the difference? Or which data set are you talking about? That's what I'm asking. Can you be able to unmute so that we can move past that issue? So do you mean that this data, since the F is large and that the is larger than the F crit, it's null? No, David, Daudi, we don't conclude that. If your F is greater than the F critical, you reject the null hypothesis. You don't say it is null hypothesis. Null hypothesis is what you're comparing your research on. Remember when I gave the example for the fuel, you somebody comes and says, for you to be able to get to Naivasha, okay, for those who are in Kenya, for you to be able to probably cover a distance of 200 kilometers, you're going to use car fuel worth maybe $20 or something of that sort. So that's no, you're going to research data, or you're going to get data and then perform statistical operations on it and conclude if it, okay, so first what they have said or what you're researching against, that first value that you're researching against to find if it is true or not, that's your null hypothesis. So what you're finding is the alternative hypothesis. I don't know. Or maybe somebody comes ahead and says, the distance from the air travel distance from here up to here. Okay, I don't know. Okay, let us say when you're on the plane, the height from the ground is 3,000 feet, and you have that as your null hypothesis. And then you come in and you gather information or data, and you want to prove that if that is actually true or it's actually false. So what you're finding is the alternative hypothesis, but the conclusion now is going to, are you accepting that hypothesis, or are you rejecting the null hypothesis, or are you accepting the null hypothesis? So for when you're doing the ANOVA, if the F is greater than the F critical, so this is found, the F critical is affected by the alpha that we have here. That's our critical value. So it is most found using the tables. So once you find the F, which is like our Fisher's test or our Fisher's value. So once you compare the two and you find that your F is greater than the F critical, now you'll be like, okay, I reject the null hypothesis. And if the F critical was greater than the F value, you accept the null hypothesis. So I hope that is clear. Oh my God, Christopher! As the as the at the column at the count column from the result output values are off by one, so that the adding input is you use is so the adding that you took to as the labels of the group as the result of the output. Okay, I agree. I agree. I agree. Yes, I took the value that follows. So I hope that is what you mean. So it starts from 0 to, yes, it starts from 0 to. While you're presenting the data, instead of using the it having F2, you can go ahead and now state that this is economics. The other one is 69 is the nini. It doesn't mean that the value was rejected, or the first two values was rejected, because even for the first for the others, you can see it was just highlighting 26, 23, just for us to be able to know. So this is data for this column and this is data for this column. It doesn't mean that it was ignored. I hope that is clear, Christopher. Can you drop down the input section? What do you mean if I can drop down the input section? I don't understand that. At the add-in, there's an input section. I don't know. Here, or if I
I think she means this window. Yeah.
yeah, if I can
The
drop it down like that, does he mean that?
does it mean to remove the entire window or something?
But I'm using it.
Okay.
That's what I'm using to navigate the what I'm finding. So if for the next, you see, no, for we have just used the ANOVA. So if I now want to move ahead and now drop down to see the input into adding. Oh, okay, like that. So I did from 0 to 2 up to Q to 10. That is what I did. I picked from this range up to this range. Yeah. Okay. So let's move on. I believe you're now okay. So you marked the labels as first row. Christopher, you can't be able to unmute yourself. I marked the labels as first row. What do you mean? Who is understanding labels in the first row? Yeah, I can remove it. Oh yeah. Oh yeah. So it's just okay. So if I say okay, okay, though I haven't highlighted, it will overlap. So it just shows me column 1, column 2, column 3. So you can remove that labels and then it will just show you column 1, column 3. So it just depends on, yeah. So I hope that is clear now. Okay. So okay, so we said that with the ANOVA we are not able to know which value in the mean was giving us the difference. So we can move on to the t-test, where the t-test is used to test the null hypothesis that the means of two populations are equal. So it just compares the means that the null hypothesis is that the means of two populations are equal. So what happens is that I am going to use the students' data we had for the male and female study hours. So I'll just copy it again, so we can work on a new data. I hope you guys are understanding. You're not totally lost. If you feel like it's getting frustrating to understand, just try and follow me as I do it. Watch the video; it will be available after the class, and just practice on it. So so I'm just stating H naught, which is the null hypothesis. Here we are investigating that mu1. I'll just write mu1 minus mu2. Okay, mu is not usually written as just a u. It has a tail. But I can't be able to do that here. But if you figure out how to, guide us. So is equals to 0. And the alternative hypothesis is that mu1 minus mu2 is not equals to. Now, how am I going to write that? Not equal to 0. Yeah. So of course, when you say mu1 minus mu2, first of all, mu means mean. So when you say mu1 minus mu2 is equals to 0, that means they are equal. So that when you subtract them, it's equals to 0. Okay. So that is that. So this is what we are investigating. So I just remove that. Okay. Okay, thank you so much, Christopher. Oh yeah, no, I'm sorry. My mind today is a little bit worn out. So t-test, two sample assuming an equal variable. So if t start is less than minus t critical two tail, or t start is greater than t critical two tail, we reject the null hypothesis. Do I need to type that? If t, okay, you'll see as, okay, let me just find the t, and then we can be able to see what we mean. So I'll pick um so we'll say t-test assuming an equal variances. So we shall first take the first data set. So the range is from A2, okay, A to up to A7, up to A7, sorry, A7, okay. And the second one is from B up to B2 up to B6. Yeah. So the hypothesized mean difference shall be 0. That is, our mu1 minus mu2 is equals to 0. And then we shall just leave alpha as is, as 0.5. And then let us display our output where we want our output to be displayed. So I'm just going to pick D1. So let me remove labels. So D1. Okay, so let us click OK. Yeah, so here is our value. Let me just increase that so we can see everything that is happening with our data set. Okay, so we can see that our mean, we have 33 and we have 24.8, and we have our variance being 160 and 21.7. So this actually gives us the variance that I was talking about, the 160 and the 21.7. If you remember, for the F-test, it gave us something different. So that means there's something different that the F-test is using, probably the n-1. And then the observations are 6, and the other one, they are 5. And then the hypothesized mean difference is 0. And then we have the degrees of freedom being 6. And then we have the t-stat being 1.472605. And then we have p probability for one tail being 0.95, and then the trick critical for one tail being 1.94, and then the probability for t for two tail being 0.19. So these are, like, they're assuming you're reading from the table. So, and then if they're giving you values from the table, and then t critical two tail 2.4469. So I'm going, like I said, if the t stat is less than the minus two critical, the negative now of it, or the t stat is greater than the positive of the two critical, we reject the null hypothesis. So for our case, it's like saying our interval is from minus 2.44691 which is less than our T stat is 1.4720605. Is it like that? No, I'm written one thing. 0204720605. Yeah, and then it is less than now the positive value of it, which is 2.44691. So since it's like that, we do not reject the null hypothesis. We do not reject the null hypothesis. And then mm, another conclusion you can make from this dataset is that if you just look at the differences between the mean, that is 33 and 24.8, um, it is not a convincing average number. It's not a convincing conclusion to say that the average number of study between the female and the male differ significantly. I want to do something. I cannot believe I can believe it, but let us do that F test again with this data set. I don't know if probably the other data set had some issues. Let us see if our F test is going to cooperate with us. But yeah, please don't be confused. I will feel a little bit guilty. Let me just confirm that this is, let me remove the labels, B2 up to B6. So alpha is 0.05. Display this in I1. Let us see. I just want to confirm the variance again. Yeah, no, it has brought what is expected. I think that the previous data set had an error somewhere. It definitely must have had an error somewhere because you can see wait, is it yeah, let me just make it adjacent to that. Yeah, you can see this is actually cooperative. So now this is going to make a reasonable conclusion because there's no way how the reason why I really didn't, I doubted what was happening in the first part is that the variances already are not the same. So there is no way I'm supposed to be accepting that hypothesis. I'm supposed to be rejecting that hypothesis. So let us make just that conclusion again while we are still here. So you can see in this case, our variances are not the same. Remember, for F-test, you're comparing variances. Your null hypothesis is that variance A is equals to variance B, and the alternative is that variance A is not equals to variance B, which now our data set falls into. It falls on the alternative because immediately we can see that our variances are not the same. So if I go ahead and now get the f value, which I told you the f value is normally this variance divided by this variance, you get this. Though now for this it just comes automatically. This you read from the table, and then and also this, and then you can see for this case now this f is greater than the f critical, meaning we reject the hypothesis. We reject the hypothesis. So I hope with that we can be able, including myself, we can just go back to default settings that this is actually how it should be working and there's no confusion. Somebody has a question? Somebody is unmuted. Has everybody understood that? Or is there anybody with a question? So I feel like there was an error in the data set before. That's why you were receiving what you were receiving. So with this, you're able to see when the mean, I mean the variance, the mean, they're all the same. Okay. So if there's no question, I want to move on to something we called moving average. Moving average. So this is we're going to see how to calculate the moving average of a time series. The moving average of a time series. So if you come here, we have this
Sorry,
moving.
actually, there's a question in the chat.
Okay, is it for t-test or for f-test? Which one? Remember, David or Daudi, um, the t-test is used to compare the means of two population if they are equal. Mean, MEAN. But the F-test is used to compare if the variances are the same. So before we had a different value. Is it this one? Yeah, here it is. And I couldn't figure out. And I remember I even told you that this is not working as expected. But I feel like there's something wrong with the data set. So, or maybe it was because of, I don't know if it's because of the labels. Probably that was creating an issue and I didn't know. I don't know. But this data set was not acting. It's in the labels. I think so because without the labels now, so you can see it as it's able now to operate as it is. It's able to operate as it is. Wait, the counts differ as well. Let me see. Observation 5 and 4. Observation 6 and 5. Yeah, so it would hit. Let us see if there's another one. Um, I think this was just for the. Did this one give us let us also just redo the descriptive analysis, I mean statistic for just our data set, just to confirm everything is working as it should. So let us remove is this labeled story. So thank you, Christopher, for pointing out that because A2 up to A5, I mean up to A7, and yeah. So the output I want it to be shown at M1. M M1. Okay, let us do that. Input range is invalid. Oh, this one had 3 values. So I hope, David, you have understood the difference between the t-test and the f-test. They are not the same. Don't confuse them. Okay, great. Okay. So let me just make sure that this input range is okay. So from A up to from A2 up to I can also just pick for one row. We don't have to keep doing for all. So I'll just do that from A up to A7, 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 A7. Okay. So yeah. Okay. So here is our output for column 1. So it just shows us yeah. So I think it's important we just remove the labels. Remove the labels. Okay. Other than that, um, let us now move on. So we have, I wanted us to look at moving average. Moving average. Moving average. I don't know. Okay, let us just first look at it. I think I should give an assignment after this class. I feel like I know this is just supposed to be like a session, but I feel like an assignment would really be great just to make sure that I'm not here performing an act, that we're actually interacting with what is being taught. So moving average, just say this is just how to calculate the average of a time series. So I had that somewhere here. Okay. Okay. So this is what you are going to be using. So for the moving average, um, we are looking at, just like I have said, how to calculate is used to smooth out irregular. First of all, it is used to smooth out irregularities. That is the peak and values. So to easily recognize trends. So you can have a time series. In our case, the period and the actual. So I can just plot. Let me just remove this chart for now. And then I can just first plot this as is. So I'll just come here, line, pick this. So you can see how that looks. So we are going now to smoothen out these peaks and the valleys, okay, using now the moving average. So you are now going to go to the moving average. You're going to input our data. And then the first thing, we are going to set an interval of 6. So we are going to keep on alternating that interval to see how, with different intervals, um, different, how we are able to now get um, the average, or just to see the difference with that. So let us do that. So we are going to first start with interval 6, then move to interval 4, then move to interval 2. So you can see it gives us that option. So let me just remove this. So your input is going to range from, yeah, it's already here. Your input is going to range from B2 up to M2. So that is this data that is here, and the actual, that is what we are influencing and affecting with the interval and everything, and removing, since we are calculating the moving average of a time series. So the period, so now we are calculating that moving average. So let us just go ahead and say, okay, I already have the output here for interval 6, so just go do the same. But let maybe I had also been affected by the labels. So let us do this together. So interval 6, um remove also the standard error. Remove also the standard error. So I'm going to display this in, let me first just delete this column, these rows here. Let me just delete them. And then, so now I'm going to display in B2, B3. I have checked out the labels and the standard errors. So our interval is 6. So you can see how it is looking. So let us plot this and see how different this will be. So I just highlight that. So you can just highlight it from the value. It won't really affect. Insert line. Yeah. So you can see how different that is. If you notice, the it doesn't have like a value in the beginning. It doesn't have a value or in the beginning with the where we have our yellow line. And also we notice that the peaks and the valleys have been smoothened out. So the graph first shows an increasing trend, and then so it is not able so Excel is not able to calculate the values of the first data points because there are not enough previous data points. There are not enough previous data points. Remember, we put our interval to be 6. So it checks from 0 to 5. It looks like you don't have enough data for us to be able to smoothen out in that range. But from this interval up to this interval, it looks there's enough. You can also add grid lines. Yeah. So yeah, you can be able to see how that looks like now. So let us affect the interval once again and see how that is going to look like. So I'm going to do interval 2 and interval 4. Okay. So let me just cancel this out. So I'm going to come here and just change this to B2 and then change this to be B4. I want it to be at display. Okay, this was 6, so I can make first the first one to be 4. Yeah, it has added. So you can just to guide yourself, interval is equals to 6. So you can just increase that here to be able to see it, and then interval is equals to 4 in this case, and then interval is equals to 2, which I now want to do. Okay, I think my net has, okay, it's back. 2. So this will be 2, and I not 2, and I want it to display at B5. B5. So if I run that, so you can see how that looks like. Um, this starts from the 6th interval, and then this starts from the 4th interval, and then this starts from the 2nd interval. Let us plot this and see how they look like. So you can see how that now is looking like. So you can see that, let me just add some grid lines. Yeah, so we can see that the yellow, or this is not yellow, the orange, which is now the actual event from our legend, how it looks like. And then we now have, but this data is going to be generated automatically once you input the intervals, the remaining data. And then we have now the blue being for interval 2. So you're able to see how that has been smoothened out from the original. And then you can be able to see now yellow being the interval 4, how that is becomes more smoothened. And you can see also for interval 6 that it is more smoothened. So yeah, any question? Any question? So I want us to move to something we call exponential smoothing. Exponential smoothing. Exponential smoothing. So we are now going to apply exponential smoothing to a time series, not to our time series, just like we did with the moving average. So it is also used to smoothen out the irregularities, and that is the peaks and the valleys, to easily recognize trends. So let us do this and see how this will look like. And what is the difference now with the exponential and the moving average. So you will see a spot written exponential smoothing. So let me find a data set that is not affected. Okay, this is actually the data set with exponential. So remember, um, oh, sorry, forgotten, I can't do that. So remember, if you want to add a chart title, you see, like, my charts are not entitled, and like for this, it would have been better if now I'm affecting this chart to at least have a heading, a heading, the chart title. So just remember that is affected. Okay. So I think it's important to do it when you're creating the chart itself. And I think we saw this in the last class or in the last session. What does that mean? Okay, just click on it. And then when you're creating it, so here you see you shall have the option chart title. So edit. So you can now write moving average. Moving average. So it will not be period, but wait, I need to, it's actually versus interval. So Doesn't make sense to just say moving average chart just for differentiation. Yeah, just better to do that. So since I didn't put that because we have the period here and we have our intervals, so probably it would have been period versus interval. Yeah, where was I? Yeah, I was here. Okay, so we are looking at now exponential smoothing. Exponential smoothing, like I've said, is just the same thing as the moving average. It is used to smooth out the irregularities, that is the peaks and the valleys, and easily recognize the trends. Only that now here we shall use something called the damping factor. And the damping factor is the smoothing constant alpha, but now 1 minus alpha is the damping factor. So if you have alpha being 0.1, the damping factor shall be 1 minus 0.1, giving you 0.9. So that's just what we shall use. So let us do that. So our input average is that. Yeah. So I'll remove the labels and the standard errors as well. So here my alpha is 0.1, but my damping factor, this one, is 1 minus 0.1, making it 0.9. So where do I want it to be displayed? I want it to be displayed at B3. So, okay. So that is what has happened. Um, okay, let us first plot that and see how that looks like. So just remember the actual head, a lot of peaks and valleys. So let us see how this will look like. Let me just add df standing for damping factor is equals to 0. Let us just write alpha. Okay, alpha is equals to 0.1. So let me just increase this. Let me plot this now. So you can see it has smoothened out the peaks and the values on the valleys of that data set. Um, let us use a different alpha and see what will happen. Let us use a different alpha and see what will happen. So I'm going to use alpha being 0.3, meaning my damping factor is 0.7, and display this in B4. So if I run that, so check the alpha is equals to 0.3. So let us run this and see how this will look like. Mm, I don't want to start at A1 because remember the first value is not really is not uh, any a value. It's just it's a text on its own right. So you shall see that with the second one. You can just change for the second one, but the reason why I'm not incorporating it is because A1 is not a value that we are using. We are using from 0 to the rest, not the other way around. For the plotting, of course, it's gonna be different because you want the plotting to also involve the wordings and everything. But when you're calculating the values, I feel like it's a little bit different. So I feel like that's going to be a different approach. So you can see now with our alpha being 0.3, it is more smoothened out than it was with the rest. Um, and it also shows an increasing trend. It also shows an increasing trend. And of course, it won't show for the first value because there is no previous data point. So that is what is happening, just like we were seeing in the moving average. Okay, so let us do the same for, let me just do with one more value and then we call this a class. For 0.8, for 0.8. I don't know, I wanted to also touch on correlation, but in matters of interest of time, correlation doesn't really have, and I feel with those basics, you can just be able to do that. I feel with what I have been able to cover, you can be able to do correlation and covariance. Those are not things that are going to be hard to do. So, sorry, the alpha is 0.8, so this is going to be 0.2. The damping factor is going to be 0.2. So so you can see input range must be a single, wait, is there a place where probably a single row or column? So this is after I have tried inputting B1. I was trying to input B1. Wait, no B2. Wait, this part. So, okay, let us say A1. So, input range must be a single. So, it's giving us an error. So, that's why we are starting at B2. That's why we are starting at B2 to answer Christopher. So, I have added on the same data set. Okay, let me just first change that. 0.3 alpha, so this is 0.7. Okay, so the next one is it's 0.8, so I want this to be 0.2 and this to be displayed at B5. So yeah, so that is that. So so this is where our alpha is equals to 0.8. So remember, the damping factor is always going to be 1 minus the alpha. Okay, so if I just map this out, what do I get? I get that. That is what I get. I able to see that it keeps on smoothening the curve, the original curve, which is in orange. So as the alpha keeps on becoming smaller, um, so yeah, so remember, the smaller the alpha, the larger the damping factor, and the larger the alpha, the smaller the damping factor. So for 0.8 is blue, it is blue. So that makes it to have more peaks. And like where our alpha was 0.1, making our damping factor to be great. So there was more smoothening in that case. And like where our alpha is big, making our damping factor small, the smoothening and hence the achieve or what you wanted to achieve is not really accomplished. So I think I can touch on well, that is something I think I can give an assignment correlation. It's not that hard, especially after what you have just done. It's something that you're just going to be able to implement. Okay, I already had it. So I think it's something I can explain quickly here, the correlations. So correlation coefficient is usually between -1 and +1. It tells us how strongly two variables are related to each other. So +1 indicates positive correlation as x increases, y increases, or as x decreases, y decreases. While for -1 indicates that as x increases, y decreases, and as x decreases, y increases. And if the correlation is near zero, it shows that there is no correlation between those values. So for this case, I was just showing the correlation. I was finding the correlation between A and B. So I input my range to be from A2 up to A6, and from but was that able to, because B2 should have been displayed with a semicolon. Let us see. I mean with a dollar sign. So remember they need dollar signs. If without the dollar sign it will show an error. Now output range, I can just say D1. So if I run that, two or more blocks arranged in rows or columns, so many are arranged in columns. Or I've known what I can actually do. I don't need to input all that. I can just say it's from A to dollar sign A2, from A2 up to B6. Yeah, let us run that. Yeah, it gives us just a minute. Sorry. So it gives us you can see now it's 1, which is actually the output expected. So another thing that was bringing that up is definitely the labels. So let me actually just remove this for now and remove this. Okay. I can just do that. Yeah, so that's, yeah, so my output is 1. So with that being said, I can now come ahead and do for the correlation of A and B on this other side. Oh, I can plot this first. Let me plot this. You see how that looks like. So that's just what I had done. I plotted it. And we are able to see how that looks like. So A being that and B being that. And remember we said that if it is positive, that means it has a positive correlation, and as x increases, y increases, and as x decreases, y decreases, and you can see that is what is happening. As it is increasing, it increases. It's kind of I don't know. It kind of decreases here, and then decreases, and then okay, in its own rate. I feel like this is up to this part, up to this corner. It's increasing, and then it goes on decreasing, decreases, and then this part covers this part, and then the decreasing goes that part. I think it's also clear that sometimes a curve might look like it's increasing, but in real sense it's decreasing. Somebody is saying I use a scatter plot. It's just the same thing, though. Okay, you can use a line, a scatter plot smooth line. Okay, okay. Did I just pick A? Look at that. Mm, okay. That is for a single value. Okay, it's acting up. So I feel probably it looks like the line is what is working for this. The line, maybe with markers. Yeah, the line is working better. Okay, so we can now show for negative correlation. Negative correlation. So with these values, you can just input from H2, H2 up to I6, and then yeah, display it in J. You can just say J1. So this was my initial value, so I'm just going to remove it. So yeah, also one thing is you can use the correl function. So if I run this, okay, I've done it twice. Um, so yeah, so it shows that there is a negative correlation between column 1 and column 2, meaning that as y decreases, x increases, or a increases, or something of that sort. So let us just plot that so you can see. So as a is increasing, b is decreasing. As this is decreasing, this is increasing. As this is increasing, this is decreasing, and etc. um yeah, Christopher, yeah, you can use the scatter from your end, no problem. So I feel like that's the end of today's class. You can just go ahead and practice on the rest. You can practice on covariance and see how that can be implemented for the analysis. Yeah, I feel like this is something now you can be able to implement and see how that is done. So yeah, in the next session, I want us to look at financial analytics using Excel, and then we shall conclude our series there. So thank you. Today we forgot to pray. So can we have somebody pray for us as we end the session? I feel like it's important to put God first in everything, especially at this time. Can we just have somebody volunteer to pray for us? Can we have nobody wants to pray?
I can do it.
Yeah, thank you.
Okay, let's pray. Father, it's another time we humble before you. We do thank you for everything that we've had today. We thank you for the session. And we do pray that may your will be done in our lives. In Jesus' name we do pray and believe. Amen.
Amen. Thank you so much, Leonard. So thank you all for sticking with us throughout the whole session. Um, okay, Daudi, I will send the data. I will try and share with it. And even if I don't, once we share the recording, you can just be able to get it, and since it's not like a lot. But yeah, other than that, thank you, Royford, thank you for everybody, and have a nice weekend. For those who are going to meet tomorrow for R, let us meet tomorrow same time. Bye bye.
Yeah, bye.